Welcome to Smart Architectural Programming. If you're reading Intro to Java book that we just published, or just diving deeper into Java object-oriented programming concepts, you're in the right place. In this video, we're exploring the powerful and sometimes misunderstood super keyword in Java. So without further ado, let's push forward and get started. So with everything, first we need to understand the significance of the super keyword first, right? What is the super keyword? And understanding why is it important in Java. The super keyword in Java serves as a reference to immediate parent class of the current object. It's like saying, hey Java, I would want to access something from the superclass. It comes in two primary forms, as you can see on the screen right now. Let me use my marker. So we have two forms here, 1 and 2, right here. And these two forms are important. The super function, which calls the superclass constructor, and super dot, which accesses superclass methods and variables. Let's see how it works, starting with constructors. But before that, let me just give you a brief intro into what superclass is. So you might have covered, and if you haven't, please go back and look at those videos, or go back and read those sections from the Introduction to Java book by Smart Architectural Programming. It is essential you understand the precepts of this concept before you get into the super keyword, because you need to understand what classes are, what classes are, what objects are, what methods are, what child classes are, what parent classes are. That is an essential concept, but I'll just briefly put it here. A parent class is, let's say, animal, right? It covers everything, right, regarding the animal kingdom. So it's covering all animals that you might want to code in your code, right? That's one. But it isn't specific enough, right? It's too broad. We're talking about animals. There are a lot of different animals, and if we write functions for an animal function, they won't be specific enough to specific animals. So we might write a child class called dog, or we might even write classes like reptiles, mammals, so on and so forth, right? So this is the child class, this is the parent class. And that is the concept you need to remember. The parent class is the superclass that we're referring to, while the child class is not the super, it's related to the superclass. So when the super constructor is called, we're trying to build the object from the superclass to reference back to for certain use cases. So with that understanding, let's move on using the super function to call the superclass constructor. So as you can see here, we have the animal class here, as I mentioned earlier, and the dog class, like exactly what I was talking about earlier. So animal is the superclass. I'm using S to symbolize that, and dog is the child class, right? So parent or superclass and child class. Dog extends animal, which means anything within the animal function is also part of the dog class, and anything addition on top of that is specific to the dog function, right? So when you create a subclass in Java, as you can see, it inherits from the superclass. I mentioned that anything in the superclass is part of the subclass. But what if we want to initialize something defined in the superclass? That's where the super constructor comes in, and that's why we use the super constructor. As you can see in this example, when we create a new dog object, the animal constructor runs first thanks to super. And if you don't explicitly call super, Java will do that implicitly, but only if superclass has no argument constructor. So as you can see, we call it here explicitly. But if you've been working with us in the previous videos on object-oriented programming, you might have noticed that usually this class has been implicitly used. So I mean, best case with everything is to say that explicitly, but it works implicitly as well. So let's move on how you can use super dot to access superclass methods. Again, as you can see the code base here, animal and animal extend. So this is the basic syntax. Super dot is just a replication of any syntax. So if you have a library, let's say math library, to access functions or methods within the math library, you use math dot, right? So it's just a reference telling Java or Java compiler or JVM, hey, go to this library or go to this particular section and you'll find the method that I'm trying to access after the dot is in this particular area. So it's a directive basically. In this example, you can see the dog barks after calling the generic animal sound. This is useful when you want to extend, not completely replace the behavior, and that is what we're trying to do here. So with that particular understanding, if you look focus here, usually we would replace the sound with just bark here because a dog has a specific bark. But in case in a function that is you're trying to use to override the function from the superclass, which is these are the same functions, but we're trying to override the superclass function here. Sometimes you might want to retain the behavior of the superclass function. So you might use super dot make sound to retain the behavior of the superclass function and run that before you come to your unique behavior for or original behavior for this particular subclass. With that understanding and that that concept, let's move on to the next section, which is how we can use super dot to access superclass variables. And it's pretty much the same here, right? Again, as I mentioned, super dot is a directional term. We're telling go to the superclass of this particular class and you'll find this particular variable or method and use that. So we have a string type called defined with a keyword string animal, and we have a string type defined as dog in the subclass. The superclass has that as animal, and the subclass has that as dog. So when we're trying to do printing action on the subclass, we print the type of this particular section, and it would immediately go that hey, there's a type key of variable here, so we'll just go there. But if we write just simply type, it's going to go back to this particular portion. But when we say hey super dot type, it's saying hey, don't go here, go to the superclass of this function and find the type variable there and use that and print that instead of what you're printing here basically. So that's what is happening here. So with that understanding, we need to develop a intuition or some rules of thumb on when you need to use the super dot for variables basically. So you use it when you have variable shadowing, same named variables in the superclass and subclass. As I showed you here, this is variable shadowing. You have a type variable here and you have a type variable here. When you have the same names, that's variable shadowing, and that is when you need to use super dot instructions to pinpoint exactly what type of which variable you're trying to leverage here, as not to have Java implicitly select the wrong variable. So next thing is basically you want to read a superclass field that's not overridden. So you need to read a certain variable or value in the superclass that is needed for your logic in the subclass. So you need, instead of to access that, to use that. And number 3, you need to maintain clarity in your code when dealing with inheritance hierarchy. So it gets very complicated when you're writing large classes, large amount of subclasses, and there's going to be a lot of variables there. So instead of just randomly typing variables, you would prefer to specify exactly which variable you're trying to get using the super dot syntax. And that helps in a sense, because when a third party looks at your code and when you're working in teams in the code, it would be much more easier for him to understand, hey, so you're trying to access that variable, instead of looking around searching exactly what you're trying to do. It's just neater that way, right? And there are 2 reasons why you need to avoid it, or 2 situations you need to avoid it. If there's no naming conflict, and if there's no conflict in the naming, and there's no variable shadowing, it creates unnecessary clutter, so you might not want to use it, right? Again, there might be contradictions here. I was saying that you might want to use it for clarity in your code when you're dealing with complicated hierarchies, but the key point was there was complicated hierarchy. So when you're dealing with when you're dealing with multiple classes and multiple subclasses, that might be where you want to give that clarity. But if you're dealing with 1 or 2 classes and some of the 1 or 2 subclasses on each of those classes, then it might be unnecessary clutter and you might not want to do that. And secondly, you're accessing private variables directly. That Java won't allow you to access private variables even if you use this syntax. So just don't try to do that. Don't create problems for yourself and your code. Remember, good design often avoids shadowing variables unless it's an intentional error for some purpose that you want to do. But at this point, just keep that as a rule of thumb. Try to avoid shadowing variables unless necessary. So I think that wraps up our exploration into the super keyword in Java. Whether you are calling a constructor method or accessing a variable, super helps you build well-structured, maintainable code through inheritance. If this helped clarify the role of super in Java, give us a thumbs up and subscribe to Smart Architectural Programming. Drop a comment if you want more Java deep dives. And with that, we're going to wrap this video up and keep coding smart.